Welcome back. In this session, we'll discuss about the basic data types in C language. The basic or the fundamental data types in C language are char, int, float, double and void. We'll discuss about void later. First, let us talk about the first four fundamental data types. The first one is character data type. The character variable is assigned 1 byte of memory. 1 byte means 8 bits. So we can actually encode 2 power 8 means 256 values. My dear friends, each character is associated with a unique integer value known as ASCII value. So I will be using character and ASCII values or the values interchangeably. Remember one thing, when you use percentile C conversion specification, character will be printed, percentile D conversion specification, then the value of the character will be printed. That is ASCII value. Okay, that is the point. See, for character data type, we also assign the sign modifier. So we have signed character and unsigned character. But C standard does not specify the default default character type. So we have to verify with your compiler. For the signed character, the leftmost bit represents the sign bit. So if it is 0, it represents positive or 0. If it is 1, it represents negative value. So we will not have 2 power 8 possibilities. We have only 2 power 8 by 2 because 1 bit is for sign. 2 power 7 possibility. So the range goes from minus 2 power 7 to plus 2 power 7, but you also need to include 0, which is neither negative nor positive, but that is included in positive direction. That is 0 to 2 power 7 minus 1. So the range actually goes from minus 128 to plus 127. You can represent this in a circle known as signed character circle. So the values goes from 0 to 127, and on the negative direction it goes like minus 1, minus 2 and so on up to minus 128. If you try to print any value from 0 to 127, the same character or the value will be printed. Means if you use percentile C, character will be printed, percentile D, the value will be printed. What happens if you try to print 128, 129? That is, if you go beyond 127, what happens? So that causes what is known as overflow. So whenever you try to print any value above 127, overflow will happen. So actually most of the compiler implement in this way, like you get the 2's complement of the number. You don't have to calculate that, my dear friends. For example, if you want to print 128, you just go in this direction. See, after 127, 128 should get. So instead of 128, minus 128 will be printed. Suppose if you want to print 129, what is the next number? Minus 127 will be printed. So the overflow will happen and corresponding number will be printed. Of course, it is implementation dependent, but most of the compiler will do this particular 2's complement value will be given as answer, my dear friend. Okay. So it is always better to verify with your compiler and check what is the possible answer. Now, what about the unsigned character? Of course, we have values from 0 to, because we are starting from 0. So the range goes from 0 to 2 power 8 minus 1. 2 power 8 minus 1 means 255. So the range goes from 0 to last number is 250. Here up to 255, the same value will be printed. But beyond 255, what happens? The wrap around. That is, after 255, suppose if you try to print 256, 0 will be printed. 257, 1 will be printed. 258, 2 will be printed. Suppose if you try to print 260, you know what happens? It prints 4. Similarly, if you try to print 270, it will print 14. We try to verify with the program. So, what we need to understand for character data type, the size allocated is 1 byte, and we have the modifiers, the sign modifier associated with character data type. So we can have signed character or unsigned character. The range is from minus 2 power 7, that is minus 128 to 127. You can use this circle, either signed character circle or unsigned character circle, to understand what value will be printed when you try to print a particular character value or a particular ASCII value. See, remember percentile C. See, this conversion specifications, please remember, for all the types, the conversion specification for the character is percentile C. But if you use percentile D, the corresponding ASCII value will be printed. Okay. So let us try one simple program. Consider the following program. Now we have this hash include stdio.h. We are including standard input output library, the main block, and I defined two character variable. One is signed character variable. I just named it as SCV identifier, and for unsigned character variable I just use UCV. So I just try to initialize them. I just try to assign some values. As I told you, 0 to 127 for signed character variable, you will get the same value. Let us try some value like 122, okay, or 120. Let us try to print. You will get some value which you know. And for unsigned character variable, up to 255, you will get the same number, 245. Now I try to print signed character variable. See, what I am trying to print is I am trying to print both character as well as the ASCII value. Even for unsigned character, I am trying to print both character as well as ASCII value. So for that, see, for each conversion specification, we should have a argument. For each conversion specification, we should have a argument. So two conversion specification for SCV, so I written SCV 2 times. Similarly, two conversion specification for UCV, so I written UCV 2 times. So this is the simple program. Now let us see the output for this particular program. And you can see the value printed X, and it is the ASCII value of 120. And for 245, this is the character, sir. See, we only know the regular character, some other character ASCII value, the character corresponding to ASCII value 245 is printed. So same number is printed. Now what if I go beyond? For example, if I try to print 130 here, and here I want to print 260, what happens? Let us try this program. Now here it is also showing you some warning message because it is gone beyond the scope. Am I clear? And as I told you, it is printed minus 126 because 127, 128 is minus 128, 129 is minus 127, and 130 is minus 126. So minus 126. In the circle, if you see, you can identify that particular number. Similarly, for 260, as I mentioned, it is printing 4. Of course, these are the characters corresponding to those ASCII values. If you want, you can try some other numbers. Let us try 270 here and 140 here. The corresponding ASCII or corresponding values will be printed after overflow. You can experiment with different values, my dear friends. So it is printing minus 116, and you see it is printing 14. If you try 280, it will print. The UCV, if you try to print 280, it will print 24. You can practice with more examples, my dear friends. And it is always better to use that signed character circle and unsigned character circle to understand what answer you are going to get. The next data type is integer data type. My dear friends, for integer data type, we have both size modifiers as well as sign modifiers. So the size modifiers associated with integer are short and long. Of course, the latest standards also include long. We are not discussing about that. So even integer is one modifier itself. So we have totally three sizes for integer: short, int, and long. For short, most of the compiler, even old compiler, they'll take 2 bytes, whereas for integer, it depends on the type of compiler. Old compiler may take 2 bytes of memory, whereas for in the new compiler, the size of integer variable may be 4 bytes. For example, I am using a compiler in which size of integer variable is 4 bytes. Almost all the latest compilers take for integer 4 bytes. In that case, integer and long are same. Even for long also, most of the compilers will take 4 bytes of memory. Okay. So again, it depends on the type of compiler. So that's why we have to discuss all the three types of size modifiers here. But the discussion we do for integer is sufficient for long also, because it is also taking 4 bytes, because we are considering short 2 bytes, integer 4 bytes. So long is also taking 4 bytes. Now again, for each of these types we can assign the sign modifier. So we can have signed as well as unsigned type of each type. That is, we have signed short, unsigned short, signed integer, unsigned integer, signed long, unsigned long. So totally this many types are possible. So we can have 1, 2, 3, 4, 5, 6 possibilities. Okay. And here one very interesting thing we need to understand is the terminology. Let us understand. See, for short, see, short, we can just represent it as short, or short integer also you can say, short int also you can represent. And when it is signed, you can say signed short int, or you can simply say signed short. For unsigned, you can say unsigned short or unsigned short integer. Okay. See, my dear friends, signed is default. Signed is default. So these two are one and the same. Signed is default. So for integer, default is signed only. So whether you say short or signed short, they are one and the same. Same is the case for integer and signed integer. Same is the case for long and signed long. They are all one and the same. So here integer and signed integer, these two are same. Long and all these are one and the same. So these are different ways of representing same thing. So whether you simply say short, or you say signed short, or you say signed short integer, all represent one and the same. Different terminologies. This many ways you can write that particular data type, my dear friend. Whereas for unsigned short, you can say unsigned short, or you can say unsigned short integer. Okay. Same is the case for integer. You can say unsigned integer, or simply unsigned you can say. See, for integer, you can ignore that int. Simply say unsigned, it will understand that it is unsigned integer. But for unsigned long, you have to say either unsigned long or unsigned long integer. Mostly we use unsigned long only, my dear friend. Okay. So of course, this many terminologies are possible. This many ways you can write the data type, but in short, these are the most commonly used forms. Okay. So we use short. Short means signed short integer or unsigned short. Unsigned short integer. Int means signed integer. Unsigned integer is unsigned. You can also say unsigned also for this. Whereas for long, you can say long, that is signed long, and for unsigned long, you have to say unsigned. Specifically, you need to mention, my difference when you are defining a variable. Remember that. Syntax we need to remember. So syntax can be written in this many ways, and mostly we use the following syntaxes only. Now first let us talk about short. The short variable is assigned 2 bytes of memory, and this is the conversion specification. This HD is the specifier for short. D, you know, integer, H is used to represent it is a short integer. Am I clear? 2 bytes. And 2 bytes means 16 bits. So 16 bits means you can actually encode 2 power 16 numbers. But when it is a signed fellow, the leading bit or the leftmost bit represents the sign. So we will not have 2 power 16, it will be 2 power 16 by 2, that is 2 power 15. So the range should go from negative to positive. So it goes from minus 2 power 15 to plus 2 power 15 minus 1 to include 0 also. So it is minus 32,768 to 32,767. Here also you can use this signed short circle to understand what value will be printed. See, within the range same number will be printed, but beyond the range overflow will happen. The corresponding numbers in the circle will be printed. So 0, 1 and up to 30, I'm sorry, we written a very big number. It's correct only, no? Yeah, correct. Up to 32,767, same number will be printed, but beyond that, what happens? The negative side will take place. That is, the negative numbers will be printed. Minus 32,768 will be. So if you try to print 32,768, what is printed? Minus 32,768. 32,769 means minus 32,767 will be. You can explore this with different examples, my dear friend. Always remember this circle. All such problems can be answered very easily. And what about unsigned short, my dear friends? Because it is unsigned, the range goes from 0 to 2 power 16 minus 1. That is 0 to 655. And the conversion specification for unsigned is U, because it is short, we use H. H you use the specifier which is used as a specifier for unsigned short. And the range, as I mentioned, it is going from 0 to 65535. Within the range you get the same number, but once you go beyond that, you have to see the overflow condition and see what number is printed for that. For example, if I do 0, 0 is printed, or 65536, 0 is printed. 65537, 1 is printed. 65538, 2 is printed. You can just go around and check for a particular number what number is printed. It is very interesting exercise, my dear friend. Here 1, here 2, like that. Okay. So for what 10 will be printed, you can try and tell me. That is maybe 65546, 65546. Maybe 10 or 11 will be printed. You can just verify that, my dear friend. Let us write down the code and verify that. Am I clear? Just go around like this. This is 39, this is 40, this is 41, this is 42, this is 43, this is 44, this is 45, and this is 46. So 10 is printed. 65546, 10 is printed. Like that. You can easily verify like this. Hope you understand. So this is about short and unsigned short, the ranges. So here the range is from minus 35,000, with 35, 32,000. I mentioned 32 only earlier also. Here I mentioned correctly. Minus 32,768 to 32,767. Whereas here it goes from 0 to 65535. My dear friends, you can use calculator and check that particular value. Okay, virtual calculators are available. Using that, you can verify that particular value, my dear friends. It is very easy to remember, whereas this numbers, okay, you calculate and remember, or you do it and remember. Okay, that is about it. And remember the conversion specifications, my dear friend. HD for signed short integer, and for unsigned short integer we can use HU. Now if you consider integer, as I mentioned, some old compiler may take 2 bytes, but we are considering 4 bytes of memory. We are assuming that integer variable takes 4 bytes, so accordingly the range is given. See, 4 bytes means what, sir? 32 bits. So normally 2 power 32 numbers can be encoded, but when you consider signed, by default I told you, default is signed. Even if you not mention, it is considered as signed only. So it ranges from minus 2 power 31 to plus 2 power 31 minus 1. So I don't remember these numbers. If you want, I'll copy from somewhere. So it is minus 2147 483 648 to plus 2147 483 647. Whereas for unsigned, 2 power 32, starting from 0, 2 power 32 minus 1. So this number is 0 to, what is this number? 4294967 And what about the conversion specification? For integer it is percentile D, for unsigned integer it is percentile E. Now you may be worried about what is this percentile I. Generally this percentile I is used together with scanf. See, if you are inputting regular integer value using percentile A, you can give that. Percentile A, if you are inputting octal value, you just need to put 0 before the number and you input. and if you are inputting hexadecimal, percentile I you give, but you write 0x and the number. So that percentile I is used mainly for scan purpose, my dear friend. Long, the story is exactly same as integer because long also takes 4 bytes. So the range, everything is same, only the syntax is different. For long, LD can be used, that is signed long integer. Whereas for unsigned long integer, we can use LU because the ranges are same, because in my compiler long and integer are taking same range, so it is not different in my compiler. In some old compiler, for long and for integer the ranges are different. You need to note that. Okay, so let us try to explore this with simple program. Now let us consider a simple program to print short variables first, then we'll take up integer variable. So I defined x as a signed short variable. Even though signed is not mentioned, default is signed. Y is unsigned short variable. I assigned the values. See, the values are within the range, so there will not be any problem. Because this one, for signed, the range we know that minus 32,768 to plus 32,767, you will get the proper answer. Whereas for this 0 to 65535, you get same answer. Whatever is assigned, the same value will be printed using proper conversion specification. So let us save it and run the program. So you can get proper answers. Suppose if I try to go beyond this range, 767, beyond that if I go 32768, what is expected? And here I try to go beyond this. So I try to print 65540. Let us see what happens. See the range here, you will get the warning message, sir, because you are going beyond the range. Overflow condition is happening. So it will, some compilers may give you warning messages, some compilers may directly run it without doing anything. Okay, so here it is clearly mentioned that you are going beyond the range. So here you see minus 32,768 is printed. Okay, the next number, because negative range, then negative, next negative number minus 32,768 is printed, whereas here 4 is printed. Okay, so you can experiment with different numbers, my dear friends. Okay, any big numbers you can try and you can experiment with those numbers. Now what if I take integer variable? Let us make it integer and unsigned integer, or unsigned, you can simply say unsigned also, because by default unsigned is understood. So for integer variable the range is much more than this. And here please don't use percentile HD, sir, because percentile HD is the specification for short fellows. So again same values may be printed. You can try that also. See, again same values are printed. Here we changed them as integer variables, but we use the specifications for short. Because of that same old values are printed. So you have to change them to D and U. So now because for integer this is very much within the range, because for integer what is the range, my dear friends? 2147 483 648. 2 same number, let us copy paste, and this should be 647, whereas here it is 0 to 4294 967 and 296. Okay, so that is the range. Within that range the numbers will be printed properly without any trouble. The numbers will be printed properly. This time you get the same numbers proper. But once you go beyond this range, for example, let us try this number which is beyond this range. See, up to here it is printed properly, but if I print 8, the negative number will be printed. Okay, here let us try this big number. I think it should be 5 now. Last number should be 1 less than that, 5. So if you print this 6, you should get 0 here. So let us try printing these values. So you see the negative number because overflow condition happened, and here you see 0. So you can experiment with different numbers, my dear friend. Just remember that circle. You can easily experiment with these problems, my dear friend. This is about short and integer. You can also try long integer, my dear friend, because long and integer are having same size, so the answers will be very much same. You can just try that, long and here unsigned long. So there will not be any difference, my dear friends. There will not be any difference. If you want, you can use LD, LU also. The conversion specification for long, you can use it. There will not be any difference. You will get the same answer because long and integer are one and the same. The next data type is float. So float appears in different forms like float, double and long double. And for float, 4 bytes of memory is allocated. For double, 8 bytes of memory is allocated. For long double, again it depends on the compiler. At least 10 bytes are allocated. Generally, the number of bytes allocated by most of the compilers for float will be 12 to 16 bytes. We will ignore long double for our discussion, my dear friends. See, most of our problems which we discuss generally need only float and double only. Am I clear? So for advanced problem, you may require long double. So the examples which we consider, okay, don't require long double. So conversion specification, we need to make note of it, and don't worry about the range, my dear friends. So for the range, you have to use this, float.h. In that you can find the ranges. It is not like the integer ranges, okay, because the float is actually depends on how the floats are represented, okay. So depending on that representation, the ranges will vary. So we are not discussing about that. You use float.h. In that we have float min, float max, double min, double max values you can find. Also you can find the number of digits precision for each of this float, double and long double fellows, okay. The number of digits of precision also you can note from that float.h, my dear friend. The macros defining the properties of these variables are defined in float.h standard library, okay. So conversion specification, you please remember, for float it is percentile f, and if you want to use scientific notation, you can use percentile e. And actually we can also use percentile g. This percentile g gives you the either floating point or in the scientific format depending on the number, my dear, okay. Percentile g also can be used. Mostly we use percentile f or percentile e for scientific form. Whereas for long double, I think it is double, there is a printing mistake, please note that. LF, percentile LF is used for long double. For double, LF is used, small l f. Whereas for long double, capital LF is used, my dear friend, okay. So this is a simple program to print the values of float, double and long double, okay. I just taken a simple example. So here also what is printed varies from compiler to compiler. That's why I am not executing and showing, sir, because float constants are by default double type. So they are converted to float type. So what answer is printed, again how it is stored in that particular memory location depends on that particular value, my dear friends. Some compiler may give you 24.56 exactly for float, whereas some compiler may give you different answer like this. Even though you store 24.56, it is giving output as 24.55999 in some compilers. In some compilers you may find 24.56 also. So it may slightly vary from compiler to compiler, sir. That is float values. That's why we don't even compare them, because we will not exactly store the value like integers, okay. So it depends on compilers. So you can try one more example, like scanning. See, percentile f is taken. Percentile f means you are trying to store the float value. Percentile LF is for double. Percentile capital LF for long double. This is one more example. Just try this example, my dear friend, okay. Now what I do is, of course we completed all the 4 basic data types. Char takes 1 byte, integer takes 2 to 4 bytes, whereas float takes 4 bytes, single precision floating point, okay. Whereas double takes usually 8 bytes. We call it as double precision floating point. So how many single precision means, again depends on the implementation, my dear friend. Okay, but in your compiler, whether integer takes 2 bytes or 4 bytes, if you want to understand, you can use one very interesting keyword, size of, okay, which is also works as an operator. So we can give the argument like the data type or the variable as the argument here and know the size of that particular data type or the variable. Okay, let us see that simple program to conclude this session. This is a simple program to check size of data types. Okay, so here it is just printing size of character. So because all the sizes are integers only, you can use %d or %hd also. They are numbers, just how much size, 4 bytes, 2 bytes, that number will be printed. So I am just sending char. See, instead of this, you can also try this. You can just define a character variable, and instead of this char data type, you can just send ch also. Even that will work. You can do it for all other data types also. You can create a variable type and you can find size of that variable type. Size of variable type or size of data type are one and the same. So let us save it and run the program. Okay. So what happened? Character 1 byte, size of short 2 bytes, size of integer 4 bytes, size of long 4 bytes, size of double is 8 bytes, and size of float is 4 byte. Of course, float should be written before double. It should be better, no problem. Then finally, size of long double. I told you now, size of long double varies. Generally, it varies from 12 to 16 bytes depending on the compiler. In my compiler, it is giving 12 bytes, my dear friend. If you want, you can write, you can create a variable and know the size of the variable, or directly data type also you give, you can know the size of. Size of tells you the size of data type or the variable, okay, of a particular data type. So this is about data types in C language, my dear friends. Thank you.